So I added a few things to the course website today. I added a final exam section. There's the practice fraction proficiency practice. That is an online practice exit exam in that new homework system we've been using. So you can go in there and just practice with fractions again. And that's like, remember the first part of the last test was show me you can do fraction arithmetic without a calculator? That's all this is, just practicing that again. You gotta show me one more time.
But on paper?
Yes, yeah, but I have some online versions here. So the practice proficiency exam, and then I've got an online version of the exit exam too that we're going to use, and we'll do that whenever you're ready for it. Just let me know and I'll sign you into it. That's going to be done with me though. And for that, you'll need to write work on paper to turn in, okay? But the problems will be presented by the computer. We'll do some of these practice proficiency problems just to review some fraction algorithms. And if anybody wants to today take that exit exam, you can take it again if it doesn't go well, but you want it to go well the first time. And then the take-home final here is the same one I gave you a printout of in case you lose it or your dog eats it. There's another copy up there, and for the people who are absent today. And then, let's see what else. Under resources, I added a sample exit exam, which is the same one I just gave you on paper when you got here today. And then I also posted a final from a few years ago. So you can see. I didn't give any to you? Oh, I guessed that only 8 people were going to come, and you exceeded my expectations. Good job. All right, let me print each of these. So the printer works today, and oops, not that one, but we can look at that one too. Page. Where is it? Oh, it's still loading. There we go. Okay. All right, so let's take a look at some fraction problems. Oh, does anybody want to print out of the final from a few years ago? Yes. Anybody not want one? Nobody said not. Okay, so.
Well, that's from winter 2015. That was 5 years ago.
Math hasn't changed much. Oop, too many. I could give you last year's, but this one I wrote more questions to practice. The actual test has only about a third of this many ones. So if I just gave you last year's to practice, that would be barely any practice. Does that make sense?
Yeah.
Okay, so that's coming to the printer. All right, so practice exit exam. Let's take a look at problem number 5 on there. Problem number 5 says, what is -2 minus 2/5? Write something down. So this is the sample exit we're working on now. This is the actual take home. This is the sample from the last year. Not last year. So the sample final is totally optional. You don't have to do it. You don't have to look at it. It's just examples of problems whenever you do.
Well, they took the pin out. It could be up to 30 degrees off for it to be normal. It's at 30 degrees off because, you know, she's a stubborn child who wants to do everything on her own. So she's still in a sling and we find out in 2 hours if she has to have surgery again. And she's still acting like, you know, day after surgery, she had her little sister in a headlock. She's just
trouble. Eek. Is that the right one? -5 minus 2/3?
Choose with negative 2.
2/5. Oops. I have that all messed up. Yes, I need better glasses. 2/5. Okay. So, suggestions on what to do here? Common denominator, yeah. So I would rewrite this as -2/1 minus -2/5. Common denominator should be 5. So I could multiply top and bottom by 5 on this one right here. So that's going to give me -10 minus 2 over the common denominator of 5, which is -12/5, which is a perfectly acceptable answer. How many of you like mixed numbers? Depends on the day. Sometimes I do, right? If I wanted to make this a mixed number, the negative just kind of hangs out. And then I just say, well, 5 goes into 12. How many times?
2.
2 times? With what left over? Out of? Notice any resemblance between that number and the original number? The original problem, right? Pretty much the same thing. Okay. Alternate approach on this, which is pretty similar, -2/1. I think that is an important idea. Oops, I threw an extra negative in there somewhere. Sorry about that. -2/5. I could use the arrow algorithm. Remember that? Arrow algorithm works on addition or subtraction, and it just says multiply across for a denominator. Cross multiply. 5 times -2 is -10. 1 times 2 is 2. What am I doing with these two numbers? Subtracting them, right? What's -10 minus 2? -12/5, same answer I got before. Okay. So I could think about a common denominator. I could use the arrow algorithm. Those are our main two algorithms. Questions on this one?
You can use the arrow algorithm on subtraction and addition.
So we have arrow algorithms for addition, subtraction, multiplication, and division. So we're going to review each of those. All right, how about let's jump to a division problem. Number 12. All right, so first step with division of mixed numbers.
I would put them into a new problem.
You have to. Yeah, you have to. So rewrite them as improper. So 2 times 4 is 8, 9, 10, 11 fourths. Divided by 1 times 2 is 2, plus 1 is 3 halves. And the arrow algorithm here starts on the second fraction and crosses. So 3 times 4 is 12, 2 times 11 is 22, so the answer is 22/12, which can be reduced. On any important endeavor like this, you should write down what you're doing, not just think. divide by 2 to simplify this. So I'm going to write down 22/12, and I'm also going to write, let's divide by 2 top and bottom. 2 goes into 22 11 times, 2 goes into 12 6 times. That is a perfectly acceptable answer. You could stop there. For those of you who love mixed numbers, you could take it a step farther if you wish. 6 goes into 11 once, with 5 left over. On a test, unless you're asked for multiple answers, just give one. It's a good strategy. Don't put an or there, because what if you're wrong about one of them? Then you're just wrong, right? So just don't do that. So either circle that or circle that. Don't circle both of them. Just to be safe. Tests are stressful. Keep it simple. Alternative approach is the division algorithm is to multiply it by the reciprocal. So division is multiplying by the reciprocal. So what does reciprocal mean? Flip. Okay. Now, what's easier to flip, 1 1/2 or 3 halves? 3 halves, yeah. 3 halves flipped is pretty straightforward. It's just 2/3 when you flip it. So I have 11/4 times 2/3. And then what's our multiplication rule?
So across.
Yeah, so arrows just go across, left to right. So 11 times 2 is 22, and 4 times 3 is 12. We could reduce. 2 goes into 22, 11. 2 goes into 12, 6. So there's my answer. Just for a second though, what if I said, you know, I love mixed numbers. Forget about improper fractions. Let's copy this thing and get a little crazy. So I want to rewrite this as multiplication, so that's 2 3/4 times the reciprocal of 1 1/2. What's the reciprocal of 1 1/2? Is it 1 2 over 1? Reciprocal means flip it, which basically is like doing 1 over. So that would be the reciprocal of 1 1/2. 1 over 1 1/2. Now we're way worse off than we were when we started. We got multiplication instead of division, that's cool, but now we have a fraction within a fraction, which is troublesome. So
Wouldn't you turn that one over 2 over 1 as well?
you can't flip them separately. Because this thing right here, they aren't a 1 with a half next to it. That really means 1 plus 1/2.
No, I'm not talking about the reciprocal. Like if you were to go through with doing it that way.
You could do it this way, but the bottom line is you still have to do some conversion to a mixed number. This is just a mess. Could somebody make something out of this mess? Yes, they could, but I'm not even going to try. Because it's just way easier to just make them improper. So whether you're adding, subtracting, multiplying, or dividing, if you have mixed numbers, make them improper, then do the calculation. That is way easier all the time. And sometimes it's just impossible to do it otherwise. All right, let's try another one. Does anybody have one that looks exciting on that paper?
Yeah, the backside.
The backside. Okay, so I said the backside is optional.
Oh.
We covered all of that stuff last quarter. I reviewed it a little bit at the beginning of this quarter just because we need to know GCFs and LCMs because that's part of the standard algorithm for adding fractions, which we'll review in a minute.
So optional being.
It's not going to be on the real exit exam.
Oh. It's just a practice.
Yeah. How about number 15? All right, so mess around with it, try something, see what happens. I'll write out some work. Order of operations is what matters here.
Oh, wait.
You don't even have to put it into a fraction first. You can just put it
Okay, if I didn't make an error, I think that's the answer.
I did it differently, and I feel like I know I'm wrong, but I want to know why I'm wrong.
Okay, what'd you do first?
I did the parentheses part first, but I didn't do 8 and 6 like over 1. I just did 8, take away 6 since they're both goals, and then that would have been 2 times.
So what's the order of operations?
So parentheses.
So order of operations says you gotta do parentheses first, right? So that's what I did first. What does the order of operations say to do next? Subtraction or exponents? So you chose to do subtraction, so you chose to do a different order, is the problem. Yeah, so although there is that's a very, I'm 8 minus 6, I love that, that's 2, right? So I put that there as like I was trying to tempt people to betray the order of operations. Got to do the multiplication before you can do the subtraction. You got to do the exponent before you can do the multiplication. So after I get that 13/3, I put it back in. I got to square it next. Square means multiply by itself. Okay, so then I put that back in. I would love to do 8 minus 6, but I can't because order of operations says I got to multiply before I can do the subtraction. So then you got to take, okay, what is 6 times 169 over 9? So I did a little reducing first. 3 goes into 6 twice. 3 goes into 9 3 times. And then 2 times 169, if I didn't mess that up, is 338. 1 times 3 is 3. So I brought that back in, so that's the result of that. 8 minus 338 over 3. I use the arrow algorithm on that. And so that gives me negative 24 minus 338, which is going to give me a negative answer. So negative 314 over 3. Does this reduce? Well, 3 plus 1 is 4, plus 4 is 8, so 3 does not go into 314. I could make it a mixed number. I don't need to. So this is, I think, the best answer right there. Negative 314 over 3. Okay, so the point here was to just follow the order of operations. Do the parentheses, then do the exponents, then do the multiplication, and then do your subtraction in order. Yeah.
So I got lost somewhere on the top. So did you square the 5?
Order of operations, you got to do inside the parentheses first, right? So I had to figure out what is 5 minus 2/3,
Okay.
and that's what I'm doing right here. And then I put it back in, the parentheses, because now I can square that. Could you try to square the 5? The answer is yes, but that makes the problem messier.
Yeah, they just kind of.
Because then what happens is you're going to have to view it this way. 5 minus 2/3, is that what it was?
Yeah.
Squared means that you have 5 minus 2/3 times 5 minus 2/3, which means you have to distribute. So not only do you have 5 times 5 and 2/3 times 2/3, but you have to take 5 times 2/3 there, and this 5 times, what did I do wrong? It was this 5 times 2/3 right there, with an extra arrow, which is just way harder. Get out of there. So it's doable, but it makes the problem way worse. The point of this problem is follow the order of operations. And you just got to write a whole bunch of stuff down. Is this a problem you should do again to double check? Yeah, because as I was doing this, I'm like, did I get that right? Maybe I should do it different, just to double check. This subtraction I had to rewrite in the correct order because my brain can't think it the other way, which is the way our brains work for most of us. All right, I think we'll stop here. So you have some homework. Oops.